All right, so here we're talking about nth term, and nth term is it's to do with sequences. So if I make a sequence which goes up by the same amount every time, it's going to go 1, 3, 5, 7. Then because I've gone up by the same amount every time, I've added on 2 every time. That means I can work out what comes next by just continuing the pattern to get 9. And that's fine. That's got me the 5th term in the sequence. We already had the 4th and the 3rd, etc. But what if I wanted to jump straight to the 20th term in the sequence? There must be an easier way than adding on 2 another 15 times. And there is an easier way, and that's what nth term is for. So the nth term is the rule that tells you how to work out any term in a sequence. So the nth term is going to look something like 2n plus 1. There'll be a number that goes before the n, and there's a number that you add or take away afterwards. But how do we get from that algebraic expression, the 2n plus 1, how do we get from that to working out what this sequence actually looks like? Well, to work out the first term of the sequence, we're going to replace the n with 1. Because it's the first term, so replace the n with 1. 2 times 1 is 2, plus 1 is 3. The second term of the sequence is going to be replacing the n with 2. So 2 times 2, which is 4, plus 1, which is 5. Third term in the sequence, we'll replace the n with a 3. 2 times 3 is 6, plus 1 is 7, and then we can start seeing the pattern. They're going up by 2 every time. So the fourth term, I think it should be 9 because we're adding on 2 every time, but let's check. We replace the n with a 4, 2 times 4 is 8, plus 1 is 9. And you can see now that I could work out the 20th term by just doing 2 times 20, which is 40, plus 1, the 20th term would be 41. But sometimes it's the other way around. Sometimes you're given a numerical sequence. Let's have one that goes down this time. No, let's start with one that's increasing. Let's have 4, 7, 10, 13. So sometimes we have a sequence like this, and we have to work out what the nth term is. So how do we write the sequence as something like 2n plus 1? Well, there's two parts. Like I said earlier, there's two parts to this 2n plus 1. There's the number that goes before the n, and the number that you plus or take away afterwards. So we know that our rule, our nth term, is going to look like something n plus or minus something. To work out the number that goes before the n, that's where you're looking at what the numbers change by every time. So in this case, we're adding on 3 every time. So the number that goes before the n is 3. To work out the bit that comes after the n, the plus or minus part afterwards, there are lots of different ways of working it out, but I like doing it this way. It's almost like cheating, but it works, so let's do it. What would come before the first term in this sequence if there was a number here? Well, if we're going up by 3 every time, then the number that would be before the 4, if there was a number there, we'd have to take away 3 from the 4, we'd have to go down by 3, and we'd get 1. And that's positive 1, so the bit that comes after the 3n is plus 1. I'm a bit tight on space actually, but let me do another example of that. Let's have a different sequence, and we'll have one that goes down this time. Let's go 5, 3, 1, negative 1. And I want to work out, again, the nth term. So I need the number that goes before the n, and I need the number that we plus or minus afterwards. The number that goes before the n, we have to work out what it's changing by every time. And this time it's going down by 2. We're subtracting 2 every time, which means the number that goes before the n is minus 2. So it's minus 2n. And then we want to work out what we plus or minus afterwards. So like we did last time, we go back by 1. We try to think what would go before that 5 if there was a number there. And if we're subtracting 2 to go forwards, then we have to add 2 to go backwards. And 5 plus 2 is 7. And if that's a positive 7, so the bit that comes after 2n is plus 7. So this, minus 2n plus 7, is the rule for this sequence in red here. But sometimes these questions can look a bit different. Here are 3 patterns made of matchsticks. I actually snipped this from an exam question, and I believe the exam question was asking how many sticks are used for pattern 6. So we want to know sticks for pattern 6, question mark? And this is an nth term question, even though it's kind of hidden. And what we're going to do is we're going to make our own sequence of numbers, a bit like the one that I had in turquoise here and the one I had in red here. We're going to make our own sequence, which lists the number of sticks you need for each pattern. So in pattern 1, you need 5 sticks. For pattern 2, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. For pattern 3, it's the 9 from last time plus 9, 10, 11, 12, 13. So this is our sequence of the number of sticks you need to make each of the patterns. Now, I want to know the nth term for this, because if I know the nth term, then I can work out the 6th term. So it's going up by 4 every time. We're plussing on 4, which means our nth term starts 4n. And to work out the sort of plus or minus part afterwards, we go back by 1, like we did last time. And if we're plussing 4 to go forwards, then we're subtracting 4 to go backwards, which gives us 1 back here. And it's positive 1, so the nth term is 4n plus 1. So to work out the number of sticks in pattern 6, we do 4 times 6 plus 1. 4 times 6 is 24, plus 1 is 25. So that's the number of sticks you need for pattern 6. But that's the more complicated type of question. Normally, you're just going to be given an nth term, which is what we did here. You might be given an nth term and then asked to list the 20th, 30th, or even just 10th term in that sequence. Or it could be the opposite way around, where you're given a sequence and you have to work out what the nth term is. So what I've got here is one of each of those types of questions. In the first one, you're asked to find the nth term, and in the second one, you're asked to find the 30th term. And if you would like, you can pause the video here and have a go at those questions, or just leave it playing as I talk through the answers. So pause here if you want to have a go at them, and I'm just going to talk them through. So the nth term of this sequence, like we've done before, we need to find out what it's going up by, or rather what it's changing by every time. And we can see that it's going down by 5 every time. So that minus 5 is what goes before the n. So that's the first part of our nth term. And then to find the bit that we plus or minus afterwards, we go back by 1. So what number would go before this 12 if there was a number there? And if we're subtracting 5 to move forwards, then we need to plus 5 to go back by 1, and 12 plus 5 is 17. So 17 is the number that comes after the minus 5n. So minus 5n plus 17 is the nth term. And then for this second question, we're going to have to work out the nth term again, but then we're going to have to substitute the 30 into the nth term to work out the 30th term. So again, we're going to need to know what it's changing by every time, and we're plussing on 3 every time, which means it's going to be 3n. And to work out the bit that we plus or minus afterwards, we have to go back by 1 to work out what would go here. So we'd have to subtract 3 to get negative 1, which means the nth term is 3n minus 1. But we didn't want the nth term specifically, we wanted to know the 30th term. And to work out the 30th term, we have to do 3 times 30 minus 1. 3 times 30 is 90, and 90 take away 1 is 89. So the 30th term in the sequence would be 89. That's nth term. That's it. Yeah, that's nth term. I hope that helps.